Hey guys, welcome to the channel. I have another interesting video here. This time I'm working on a 2011 Chevy Traverse. This is sent by me by Nick here in Tysons Corners in Virginia. Hi Nick, this is your computer. I'm going to just give you an update. Yep, I tried to repair this computer first. I didn't have any fireballs or communication with the computer, and I ordered some parts trying to help them out. This is again a no start, no communication on the vehicle. So the first thing that I want to show is this computer I have right now, just a multimeter connected to the CAN network on CAN high and CAN low, and so is the oscilloscope. But I'm reading 120 ohms. So in this one, I don't need to provide a CAN resistor in order to communicate. So I don't need to do that. So what I'm going to now do is I'm going to move my multimeter over to the sensor ground and the sensor power to see if we now got 5-volt reference, because what I did on this one, I replaced the voltage regulator CAN transceiver. It's all built into one, and this is a 30, let me make sure I got that correct. 3622 is a Bosch device. Again, this is fuel pump, 5-volt reference regulator. It controls multiple relays and so as a CAN transceiver internally here. Reason I know that is I already have worked previously in many of these computers. Not really successful too many times on these ones when it comes like this, because it can be to just the regulator or have damage the microprocessor. In this case, I think that's the problem we have with this one. But I want to show that, my connections and everything, as I usually do. So give me just 1 second. All right, guys, what I want to show first, well, everything is as it was. I'm going to power up. I got, again, using my Siglin bench power supply, one of the channels. I'm going to provide powers and grounds to here. So the connections, for those who wants to see that, let me bring picoscope down. So these are the main signals that I use to test the computer. I got powers. I divide the connectors as they are in the diagrams as X2. So if you see here, communication, sorry, connector 2 is a 58 pin, and that's marked as X2. And connector X1 is the 96 pin. So two connectors on this computer, 96, 58. And this is X1 and this is X2. In powers, I got on connector X2, again 58 pin, 356, and then 54 as ignition. A battery supply and connector X2, 56. Battery, wake up. Again, it's a battery source, so voltage supply, X2, connector 41. Sensors grounds, I have an X1, 41, 42, 44, 46, as you can see here. And then also an X2, sorry, that's an X1, yeah, X2, all this. Grounds for the computer are all in connector X2, 1, 2, and 4. Those are the big pins. And then communication happens in the same connector X2, 58 pin, and 42 is scan high, and 55 is scan low. The rest are just 5-volt reference 1, 2, and 3, because this computer has 3 5-volt reference. I also mark, take the board, and then do my markings as far as, like that when I'm looking at the board from the tab, I know exactly where powers and grounds and everything has to go. I also mapped out all the way to this component, the can high, and you can see here, if I zoom in here, I mark where 55 and 42 again, can high, can low, reaches this 3622. So this is again a CAN transceiver regulator. This provides the sensors, grounds, sensor voltages, 3 5-volt reference, and also provides the 3.3 in the 5 volts for the microprocessor, which is right here. All right, so for this computer, I didn't have a 5-volt before, so I'm going to power it up, and we will see immediately how I get 5-volt reference. So it is definitely an improvement because I didn't have this before. So if we go back to picoscope, yes, we got on the CAN high and CAN low, we are getting voltage as recessive voltage, like when it's no communication, 2.45 volts. And red channel is just a match of that. So it's right behind the the blue channel, and it's n no activity. And this is telling me that we have a problem on the microprocessor because everything goes from here to there and then to the microprocessor. Fiber reference, this is not a microprocessor that you can actually check the pins as all the bolts are. It's not a component like this that you have legs to check. So there is also test points in all over the board that you can use to check that. And I already mapped those out, and I know that direct line communication wise from the microprocessor to the firewall regulator CAN transceiver and then out. All is good. All paths are there. Still, I don't see activity. It, as soon as you power up a computer, the computer has to send a signal, I'm here. It doesn't matter if it doesn't send messages constantly, but you have to have a message of I'm here, waiting for response, especially a main component like the engine computer. All right, so what I'm going to do now is, as you can see, I have the scanner disconnected. It's not connected to the OBD port. I'm going to connect this. Give me just 1 second. I'm doing all one-handed. So as soon as this was power up, it takes a little to get the power to the. As you see that it's booting up, and we will see shortly how we'll start getting messages, but those messages are not from the computer, will be messages coming from the diagnostic tool, right? So, but either way, I will try to establish communication. So let me lower actually the blue channel and the red channel so we can see that behind the scanner. Yeah, that's a lot better. So we can see we got nothing in there. The settings on the scope is I got 100 microseconds. I got 5 volts per channel. You can select filters, but I can do that after capture. This is a very capable oscilloscope thing that you will notice immediately if you're using the Picoscope 4425. You will never get a sample rate of 1.25 gigasamples. You can see the samples are 1.25 million samples. That is huge compared to any picoscope. So for FlexRay, CAN network decoding and everything, this is a much more capable oscilloscope than the automotive one. All right, so this is why it's like that. All right, so going back to, I will just select auto scan, and we shortly will see some going on the CAN network on the screen, hopefully. Okay, there you go. And we can see now activity, and that is now the scanner trying to see if somebody is there. Just moving the trigger to make sure if we see, yeah, right there is another and no communication. So I can stop this, and if I go back to the captures, probably not enough windows. I should have to stop because I got 100 microseconds. I can actually, based on what I have here, I can go even 10 milliseconds per division. So let me rerun this. I'm going to skip this and then retry to scan the car so we can see again there is no communication in here. Let's wait for that, and I'm going to stop the oscilloscope as soon as I see that on the screen right there. So that's good enough. That's the scanner trying to, are you here? Are you here? Are you here? Is anyone here? Anyone? Respond. No respond. So yeah, this is a little disappointing. Sometimes it's just the way it is. Computers and electronics are very picky. So if it's a short voltage, a low voltage cranking can corrupt microprocessors, and those are things that we cannot change. Yeah, there is some instances, and you can reprogram and reload the calibrations on a microprocessor when you get activity. If the microprocessor will be sending at least activity back and forth in here, I can do a calibration and save the computer. But when you have no response, there is no messages coming out of the microprocessor, that's it. There's nothing I can do. You can try to do BDM, going in the board. Believe me, I got plenty of experience on this, and this is not a good sign. So I'm deeming this computer not repairable. There's nothing I can do. I try my best to help the customer, but it's just a point for my time and investment on something like this, and it's just again, an end to it. But yeah, so going into what we see here, let me just do a zoom, and we will be able to see again the CAN network. We got a lot of hash and noise in here because obviously we were out, but not enough to really create a problem on any of the signals. We got a little bit of a ringing in here. Let me go back to the zoom before. Let me actually, before we go there, apply a filter, and this is something you can do, and you will immediately see how big of a difference is to each channel. We can now raise this up and then start to see a little more of what we're doing in here. All right, so I'm going to put like 4 megahertz filter. I'm going to do the same thing on the red channel, and it seems like Picoscope corrected that little glitch that was before, because in the last update, before when I was trying to get the filter on the next channel, I have to go to another channel because the second one I selected didn't change. But now it's good. So thank you, Picoscope, to correct that. And now if I do, this, then we can see again package of messages. And we can do the same thing as I was showing yesterday or the day before on the hybrid vehicle. When you're doing any diagnostics on a CAN bus, you want to do A minus B. And what that will do is create what the rest of the components or modules on the network is seeing. In this case, I can actually just select the views and I can deselect A and B, and then we can just see that match channel. If we go over to this match channel, then we should be expecting to see 0 to 2 volts, right? That's what the computer most often will see. So it's backwards because of the way the channels are. But yeah, we're going from 0 to 2.3. So again, this is very healthy reading. The computer will not complain. Everything is there because that's the scanner. So any module will respond to this message properly. But we got a dead computer. So again, Nick, sorry I have no good results with your computer. I try my best, and when I saw that situation of no 5 volts, I was very, very happy to see that because when I usually have no 5 volts, it's usually the regulator and capacitors and so on around, which if I get closer, you will see all the changes I do. And I can show you, actually, let me just get the camera because I am very proud of my work, and I'm going to show you in close capture that if anyone comes and see this computer, they will not even know that I was here because my work, my solderings are really, really like factory. So you will not be able to really see that someone was here. I'm trying to get this to focus, so let me just get the height correct. I'm trying again to get it to focus. It was just too close. We're getting there, so give me just 1 second, guys. I'm trying to put this into a high day. We're all good. Come on. Let me pause. Let me set up this and I'll be right back. All right, so the camera, I'm gonna move my hand so you guys can see that that is actually here and it's not a picture. But yeah, as you can see, it's this the same 3622 is a Bosch component. And if you go and look around, I mean, every single solder joint is like factory. Again, nobody will ever even know that I was here because that is perfect positioning, distances. I'm very, very careful to make sure that the distance from here to here, from here to here is exact. So no one will ever know that this was done by a human. So, but yeah, so, and I replace all the components. So yes, again, I'm going to put this on next to it and you will be able to see uh, that yeah, when these ones are removed, the only way to get it out is pretty much a lot of heat and then yank it or lift it up because they have all this glue, gray paste that they put. It makes it very hard to remove. We can see all that also here and here. So this is a heat dissipating compound that dries up and almost create like a bond, like a glue. You can see all that in here as well too. But yeah, so again, I don't want to take much longer of your time. This is in this time a not repairable computer, and this is as much as time I want to spend on this. All right, guys, I just want to share also that sometimes it's not possible to repair, and you have to just, be realistic. Don't try to be the hero and spend hours and hours and hours in something that is not really worth it, because you will not get a good conclusion. If you want to take it as a learning lesson and you want to spend time and decipher the entire board if it's yours, okay, well, then you can spend as much time as you want. Me as a business, I know exactly what I'm going, what am I doing, and how much or how deep I will go before I condemn a computer as bad. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.